All right, so the topic we can see is characteristics of a quadratic function. We're just talking about a couple of them. So we're going to start with this vocab word of zeros, and this is going to come up a bunch, and then it repeats itself in Algebra 2 a lot. Like right now, actually, in Algebra 2, they're talking about zeros as it refers to cubics, quartics, quintics, and higher degree polynomials. But our focus right now is quadratic, so degree 2. So a zero, this is simply the x-intercept of a parabola, or in this case, a quadratic function, right? So it's just the x-intercept, in our case, is the 0 in our case is going to be the x-intercept of a parabola. As we move on in chapter 9 and start solving quadratic equations, 0 is also going to mean solution, so I think we might as well write that down as well. So it's the x-intercept, and that at the same time, it's also going to be a solution, right? So I want you guys to think for a second, how many, if it's the x-intercept, right, and we already had a parabola on the board earlier, how many zeros can a quadratic have? So I'm asking you guys, what do you think? How many zeros can we have? Michael? 2. Okay, so we have 2, and visually that would look like this. So if we drew a picture, we'd take our, let's just say we had some parabola and it looks like this, right? That's a parabola. It has 2 intersections of the x-axis, so this would be a 0, and this would be a 0. If we actually put numbers to it, maybe this is 1, 2, so this has a 0, this is the point 2, 0. So we have an x value of the 0 is simply the number 2. And then here, maybe this is 1, 2, 3. And so then that's a negative 3, 0. You can write zeros as ordered pairs or just the x value, right? That's the same way we wrote y-intercepts when we talked about linear functions. We wrote them as ordered pairs or just the y value. It's the same idea. All right, is this the only picture we could have? Abigail, give us another one.
You could have one.
Okay, we could have 1. And Abigail, what would that look like if we just had 1?
The vertex is on it.
Yeah, so maybe it looks like this. And that's our vertex is on the x-axis, so maybe this is at the point 1, 2, 3. So that's at 3, 0. Is that it? Grace?
Did you have 0?
Yeah, that was actually our picture earlier today. You can have no x-intercepts, so you can have 0 zeros, and that would just simply look like something like this, right? So this also tells you if x-intercepts is also the word for solutions, when we get to solving quadratics in a couple weeks, these are your options. Anytime you solve a quadratic, you can have no solutions, you can have 1 solution, or you can have 2 solutions, right? That's what it's going to look like. Okay. So these are our zeros, right? So we'll work on identifying them later, but really you just need to look at your graph and identify the x-intercept, right? All right, so then the other thing that we want to focus on today is called the axis of symmetry. So I want you guys to jot this down, right? I just pre-wrote a couple notes. And if you don't want to write axis of symmetry over and over, feel free to be lazy and just write AOS as long as you know what that means. All right, so just as you guys write that down, let's read it out. Parabolas are symmetric. So we've seen that those U shapes, they're symmetric. So this means that they're symmetric across a vertical line that passes through the vertex. So let's just I'm just going to redraw one of those graphs I just drew on the previous page. So if you already drew it, it won't matter. So we had a parabola that looked something like this on the previous page. So the axis of symmetry is going to be the line that passes through the vertex and cuts this in half. Okay? And so that means this one would look something like this. It'd be right here, it would be a vertical line that passes through the vertex. Now, vertical lines have what type of equation?
inequality?
No, we're talking about lines. We don't want inequalities. Think back. Final exam question. I think there are 2 or 3 of them. Vertical lines of what type of equation? Like, what do they look like? Look.
Like, just one half of the thing is.
Okay. There we go.
You like x equals.
X equals, so all of our answers are going to be x equals. Because vertical lines have x equals. Now I drew a dashed line, it's not an inequality, but just so it didn't interfere with the fact that our parabola is the focus. So, okay, how do you find your axis of symmetry? Well, we have a couple different ways. One is if we take the picture I just drew, which is more or less the same picture we drew on the previous page. One way is to take the average of the zeros. Because this is symmetric, so these 2 points here and here are the same distance, equidistant apart. So if we took the average of them, that would tell us where we split this graph in half. So in this picture, we have a 0 here at 2 and a 0 at -3. So average would mean add them up. So in our scenario, -3 plus 2 over 2. So this is -1/2, and this is an x equals. And that's where I tried to draw that blue line. I know it's kind of curved. But that would be our axis of symmetry. That is the line that cuts the graph in half, meaning the right half of this graph, if we were to fold it and flip it over, it would match up perfectly with the left half, right? If that was our crease and we folded it over, it would match perfectly. Okay. So this is one way that we can do this. We can go ahead and take the average of the zeros, right? So if we went back to the previous slide, we just did this problem, right, where we had 2, we took the average of these zeros. But what about in this one? There's only 1 0, but the axis of symmetry, it still goes through the vertex, right? So we still have an axis of symmetry, it would look like this. What's the equation of that line that I just drew? There's only 1 0. Look.
You just use the vertex because it is the 1 0.
There you go, it just is the 1 0, so you just take the x value, x equals 3. Right? And that makes sense because when we wrote these vertical line equations, all you're doing is identifying the x-intercept, right? That's all we did when we wrote them, because that's what it's telling us. This line is vertical through the x-intercept of 3. And that matches the x value of the vertex. This one we would need something else, right? This has no zeros, so we can't use this idea, but we could. We're going to talk about how we figure out something like that, right? So we're just going to take the average of the zeros, that's one way. The other way is called an axis of symmetry equation. So I want you guys to have in mind our general form, right? The general form is ax squared plus bx plus c. This is a reminder. Remember, this is the general form. This has nothing to do with our axis of symmetry, but we're going to refer to it. All right, so our axis of symmetry equation. We need a little calculus to come up with this. I don't think it's worth our time for me to show you like how we get to here, just because it involves a lot of math that we haven't talked about. But you're going to have to trust me on this. The axis of symmetry, it looks like this. X equals -b over 2a. Circle that star, highlight it, make sure it stands out on your paper. Axis of symmetry, it's an equation you need to know. So if I just made up an equation, maybe we just pick something simple like y equals, let's go with 2x plus 2x squared plus 8x plus 1. Let's just fill this in together. So everybody, what, in this new equation, what is our b value? What's the b value? Just call it out. 8. Okay, so we know b is 8 in this case. What's our a value, everybody? 2. So then we would plug it into our equation. So x equals -b over 2a. So this is -8 over 4, which is x equals -2. So that would be the axis of symmetry equation. And this is going to help us graph, right? I said we're building a foundation today and yesterday. We're working on that foundation. All right, so let's put this to use in our first problem for the day, right? That's a long since this is tracking our time. It's a long time to just talk and not have you guys work on stuff. So let's do our first. Not here. Eiley, what are the 2 zeros in this graph?
1 and then 5.
Yeah, 1 and 5, right? So those are our 2 zeros. So if we took the average of them, you get 6. Add them up, 6. You divide by 2, you get 3. Plus, in this, the way that this is drawn, we can already see that 3 is the line that cuts this in half. So our answer as an equation is x equals 3, right? All right, Tommy, coming back to you. What is our axis of symmetry equation? So x equals
negative b negative over 2a.
Yeah, negative b over 2a. So we're going to end up filling that in. All right, Michael, fill that in for us.
It'd be x equals 4 over 2.
All right. It is x equals 4 over 2, which is better known as 2. There we go. So that's our axis of symmetry, right? It's going to be what cuts our graph in half. Okay? Now, if you also notice, this, someone raise their hand and tell us, what's the ordered pair of this vertex? Michael.
3, negative 4.
Alright, so 3, negative 4. So what we will find out is that the x value of the vertex is always the same as the axis of symmetry, right? These are always the same thing, which is really nice. Okay? Because then if we want to find the y value, we don't have to do much work. So let's talk about the vertex then, to finish up. So we already know that the vertex is the highest or lowest point on the graph. So we know that. But we need to be able to find the vertex, right? So let's take that equation we just had down. So I believe that equation was y equals, was x squared minus 4x. What was the next number? Was it minus 10? Thank you. So let's look at this one, because we already did the work of finding the axis of symmetry. So let's just repeat that problem. So to find the vertex, first thing we have to do is find the axis of symmetry, which in this problem, remember, we just did this. So we already know that that answer is x equals 2, because we already did the hard work in the previous problem. If we know, and this is also, the axis of symmetry is also the x value of the vertex. You get that for free. So then if we have the x value of the vertex, what could we do to find the y value of the vertex? So we have half of it. We have an x value. Timo, you got a thought?
Is it negative?
Why don't I don't want an answer. I want to know, like, how could we get to an answer? Abigail, go ahead.
Since you know that the axis of symmetry is the x, we could just plug it all in the symmetry.
Let's plug it in. So to find the vertex, we first find the axis of symmetry, which is x equals 2. Then simply plug that in. Plug into quadratic function up above, right? Whatever that function is. So in our case, wherever we see an x, we're going to replace it with a 2 for this particular problem. So then this is going to be y equals 2 squared minus 4 times 2 minus 10, because that's plugging in 2 for all the x values. So 4 minus 8 minus 10, which is going to be negative 14. Now, make sure when you write your answer as an ordered pair. You have to write your answer as ordered pairs because vertices are ordered pairs, right? So don't just write negative 14, that doesn't make sense. Negative 14 in our case would actually be our minimum, right? Because this graph opens up, so this would be our minimum, but we don't want that. We want the vertex here. All right, Shyla, could you just fill in the axis of symmetry equation for us for this first one?
Negative 6 over negative 1, or 2 times 4.
All right, yeah. So we get to here, plug in that negative b, that's not supposed to be a b, yeah, right, 6. Negative b over 2a, and it looks like this, so it looks like we should get a 6 over negative 2. which is better known as a negative 3. Okay, and then, so this is what I was saying, we need to be careful when we plug this in. So as you write it, I would actually write this one out, negative, or opposite of, negative 3 squared, minus 6 times negative 3 plus 5. So everybody, what is negative 3 squared? And then take the opposite of that, so minus 9, or negative 9, plus 18, plus 5. So we end up with a 14 here. So our answer is the ordered pair, negative 3, 14, right? That is the vertex. All right, this was supposed to be a y equals here. Doesn't really matter. Mitchell, fill in the axis of symmetry equation for us, please.
Negative, just negative 10 over 10.
Yeah.
5.
Yeah, over 10. So we get 10 over 10, which is 1. So this one's really nice, because then when we plug that in, it's not too hard to do. Abigail, when we plug in 1, what do we get out?
5 minus 10 plus 3.
All right. So we're going to get out a negative 5 plus 3, which is a negative 2. Do we agree with these two answers?